This GCSE Maths revision, we are going to learn how to change the subject of a formula, then we solve GCSE exam questions. We are going to start with the simplest questions, and we progress to more complex questions up to question 5. So can we start with this question 1, where you are told make H the subject of the formula A is equals to B H. So when I say make H the subject of the formula, what I mean is I need to rearrange this formula such that H is on one side of the equal sign alone, either on the left side or on the right side, no problem, provided it is alone. So in this case, to do so, I have A is equals to BH. So to make sure that H remains on one side of the equal sign alone, I can divide both sides by B, this B here. So now it becomes A divided by B is equals to H. And as you can note, H is on the right side of the formula alone. So we have made H the subject of the formula. And now the formula becomes H is equals to A over B. You can also write it like this. H is equals to A over B. It's just the same thing, provided H is alone on one side of the equal sign. So that's the logic of making one of the variables the subject of the formula. So let us progress to a bit complex questions. In this question 2, you are told make R the subject of the formula, and you are given C is equals to 2 pi R. So as usual, what we need to do is to make sure that R, because it's the one we are making it the subject of the formula, we need to make sure it remains on one side of the equal sign alone. And to do so in this case, yeah, I have 2 pi R, and then I have this C. So I can divide both sides by 2 pi, so that I eliminate this 2 pi from this side, and it becomes on this side C all over 2 pi. So now it becomes C all over 2 pi, and then these 2 pi and these 2 pi cancel, so we remain with R alone. So R has been made the subject of the formula. You can write it like this too. R is equals to C all over 2 pi, and it will be the same thing. So we are progressing on well. Let us go to question 3, which is more complex than question 2. So in this question 3, you are told make X the subject of the formula, and then we are given Y is equals to 3x plus 2 divided by 5. Since here we are taught to make X the subject of the formula, what we can do is to eliminate first this denominator here, so that at least both of the sides can have no denominator. So to do so, I can say, since this 5 divides everything on this right side of the equal sign, I can just put it in brackets like this, and then I multiply the whole of this side by 5, so that such that when I divide this 5 by 5 1 by 5 1, it will eliminate this 5 here. But then again, since I've multiplied by 5 on this side, I need also to do the same on this left side. So I'll multiply this y by 5 too. So it will be 5y. So now I have 5y is equals to this 5 cancelled with this one. So I remain with 3x plus 2 like that. And then don't forget, we are making X the subject of the formula. So from there, I need to eliminate anything here, which the constants in this case, like for example, this 2. So I can say 5y, then I move this 2 on the other side, so it becomes 5y minus 2, because here it was positive, is equals to 3x, like that. But you see, I only need X as the subject of the formula. I don't need it to have any coefficient. So in this case, to eliminate the coefficient, I can divide both sides by these 3 here, which is the coefficient of X. So when I divide it by 3, then it will be 5y minus 2 divided by 3 is equals to x. And that becomes the solution for that question. Now you can see x is just alone and it is the subject with the formula. You can also write it like this. X is equals to 5y minus 2 divided by 3, like that. And that becomes the solution for that question. So, can we continue and try to solve question 4, which is even more complex than the previous questions. So in this question 4, you are told, make r the subject of the formula, then you are given a is equals to pi r squared. The first thing, as usual, is to eliminate anything which multiplies r, like in this case pi multiplies r. So we can eliminate it so that we at least remain with the r. And to do so, I need to divide both sides by pi, like this. So now I have n divided by pi is equals to this pi here cancels with this one, so I remain with r squared like this. But you see, we were told to make r the subject of the formula, not r squared. So to do so, I need to take square root on both sides here so that I can eliminate this squared, and I also take square root of this one here. So now it becomes square root of a divided by pi is equals to square root of r squared is r. This is just like writing r squared again raised to power 1 over 2, which now will be, I cancel this 2 by 2, 1 by 2, 1, so it remains to be r raised to power 1, which is r. So this becomes the solution for that question, and you can also write it like this. R is equals to square root of a over pi, like this. So can we try to solve the last question, which is even more complex than question 1 to question 4. This question here, you are told make p the subject of the formula, then you are given q is equals to 3p minus 2 divided by p plus 4. So we are told to make p the subject of the formula, and we have the first thing we have here is we have a denominator. So to do so, we need first to eliminate this denominator here, and then denominator is p plus 4. So since it's dividing this numerator here, I can just put the whole thing in brackets, and then I multiply it with p plus 4 like this, so that this p plus 4 can cancel with this one here. But then again, since I have multiplied with p plus 4 here, I need to do the same on this left side. So I'll again multiply it with p plus 4. So to do so, I need to say q into p plus 4 so that I can multiply it with this denominator here is equals to, but you see this p plus 4 will cancel with this one, so I'll only remain with the numerator, which is 3p minus 2, like that. Then from there, I can just open the brackets here, and then it becomes q multiplied by p is qp. So I can just write it like pq, like that. And then again plus q multiplied by 4 is q4, but I can write it like 4q. Nothing changed, I just multiplied this q by p, then q by 4 to open the brackets. Then from there, like I say, is equals to 3p minus 2, like that. Then I can group the like terms together at least, because here you see I have a p, 3p here, and I also have a p here. So anything where we have p, I can just group them together. So I can have pq, and you see 3p here was positive, so when it was on the left side of the equal sign, it becomes negative, so it will be minus 3p, then plus this q here, for q of course, then is equals to negative 2, like that. Now then, this one here, we have the p, and we also have we have p q minus 3p and then we also have a q here. So I can eliminate the p, put it outside the brackets like this. Then I have if I put p outside the brackets, I will have q remaining q, so that p multiplied by q will be pq minus 3, like that, then plus this 4q here, and then from there is equals to this negative 2 here. So from here I can take this 4q on the other side, so it will be p into q minus 3 is equals to negative 2, this one here, then minus 4q, because here it was positive, on the other side it will be negative, so minus 4q. But you see, we only need p. P should not have another value. So to get p alone, I can divide both sides by this q minus 3 here. Q minus 3. And then this one will cancel with this one, so I remain p is equals to negative 2 minus 4q all over q minus 3, and